À tous les DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Allumage de ESR et décollage. La propulsion est nominale. Pilotage calme.
We have lifted off. Ariane 6 and CSO3 have started their
Propulsion
journey.
nominale.
He's telling us that the propulsion is normal. We are looking here at our cameras, onboard cameras.
Tous les paramètres à
looking
bord sont
down.
nominaux.
He's telling us that everything is going normally. I believe, David, we're looking down here at one of the boosters.
Yes, that's right. These are the onboard cameras. We have a
Propulsion
cloudy day
nominale.
today, so you can see the rocket going through the clouds.
Indeed, we've already broken the sound barrier. We
Pilotage
have.
calme, trajectoire nominale, paramètres à bord nominaux.
He's telling us that everything's going according to plan. David, we can hear our rocket coming over the Jupiter Mission Control Center about 16 kilometers from that pad. It takes time for the noise to get to us, the rumble, as it's sometimes known in the jungle.
That's right, and we can feel now the vibrations of the boosters coming up to us 15
propulsion est
kilometers
nominale.
away.
Indeed, and it's those boosters which are doing all the work, even though we have switched on the engine on the Vulcan engine on the main stage. The boosters, well, their job is to literally boost us away from our
Trajectoire
planet's
nominale,
gravity.
paramètres à bord nominaux.
That's right. It's the boosters are providing more than 85% of the more than 800 tons that we need to take off, and these boosters will burn its 2 times 142 tons of
Pilotage calme.
propellant during a bit more than 2 minutes. And after that, we will have lost about 70% of the mass that we had at the time.
Of course, the faster we go, those boosters scheduled to
Propulsion
detach
nominale.
in a matter of seconds. Seeing our images here on the live cameras
Séparation des ESR.
just a few seconds after the event, but we have confirmation that those have actually separated. As I
Propulsion
said,
nominale.
the images are coming to us for technical reasons, just with a very slight delay. And he's telling us that the propulsion is nominal. And there we go. That's what it looks like in space. Those boosters falling away. The trajectory on the right-hand side of our screen. the
Trajectoire
green-
nominale, paramètres à bord sont nominaux.
Everything's normal. The green line is the planned trajectory. The cross, indeed, is our actual position of our rocket. Our speed and altitude, David?
Yes, we're close to 100 kilometers now, and we're 150
La propulsion
kilometers
est nominale.
downrange from Kourou, and we have a speed now of 1.7 kilometers per second and increasing.
Per second, not
Per
per
second.
hour, per second. So that's the kind of speeds we're going to be heading up towards. We'll be getting to 8 kilometers per second. Look at the images on the bottom right of your screen. That is the big main stage, the tank of fuel at the very front of sort of pointy section, if you like, is our fairing with our satellite inside. It's got a number of different jobs. It's protecting the satellite, isn't it?
Right, it protects the satellite while it's on the ground against dust,
Pilotage
humidity, on any kind of pollution. Then it protects the satellite during the launch itself, the liftoff, because there is a lot of acoustic noise.
Trajectoire nominale.
And finally, during the atmosphere part, then it protects it against the air friction and the extreme heat that is generated by this friction.
So our satellite nice and comfortable up there in first class inside the fairing, having started its journey. That fairing will remain there for another few seconds. And of course, as we saw earlier, David, you were explaining it's made in 2 halves.
That's right, and this is the onboard camera showing the 2 halves of the fairing that will separate.
Séparation coiffe.
We have confirmation that the fairing has separated, and we'll be seeing those, hopefully, those images on our onboard camera. It actually, as it separates, David, it flexes. It's called the breathing mode. It's very specially designed to do that.
Yes, that's right. The breathing mode. Here we go. We have the separation and the breathing mode through the onboard cameras. This breathing mode is this movement of the two halves that happens due to the forces of the pyrotechnic separation and then the ejection forces and the flexibility of the structure.
Looking back down at our planet now, you can see that thin blue line.
La propulsion est nominale.
The atmosphere of our Earth. He's telling us that the propulsion's normal, everything's going according to plan. So we're burning the main stage. It's a great big tank of fuel. David, tell us a little
Les
bit about
paramètres à
it.
bord sont
Yeah, so
nominaux.
the main stage is a cryogenic stage. It's 32 meters tall and about 5 meter diameter. It weighs 23 tons and burns 154 tons of cryogenic propellant. And it has two tanks, a hydrogen tank in the lower part, an oxygen tank in the upper part. And for those who remember, on Ariane 5 we had a common bulkhead, meaning that the two tanks were together. On Ariane 6 they are separate. This in order to improve the handling of the pressures in the tanks.
Propulsion nominale.
And in the lower part of the
Pilotage calme.
tanks, we have the Vulcan 2.1, which is an improved version of the Vulcan 2 engine that we had on Ariane 5. We have improved the nozzle manufacturing. We have gas generators which are made using additive manufacturing, and we have also added a thermal protection around the nozzle in order to protect it from the heat coming from the boosters. And this will burn for over 7 minutes, increasing speed and altitude.
Separating each section of the rocket looks simple, but of course a lot is actually happening up there, and we're getting closer now to the next main event, which will be cut off of that main engine.
Yes, that's right. It's the guidance algorithm that's on the onboard computer that will detect that we have reached the right orbit for separation. And then it will send the shutdown command to the Vulcan engine. After that, we will have a pyrotechnic separation between the two stages and a set of springs that will push away the two stages. And we should be able to see it on the onboard cameras.
You can see on the bottom right is you can see our satellite CSO3 attached to the front of the rocket, the top of the rocket.
Paramètres à bord nominaux.
Getting close now to the next event. We call it MECO, main engine cutoff.
Extinction Vulcain.
And we have confirmation that the engine has switched off.
Séparation LLPM.
And we have confirmation that the main stage
Allumage Vinci. Fin de mission sauvegarde.
has separated, and the upper stage has switched its engine on, and that's what it looks like up there in space with our onboard cameras. That great big
Propulsion
tank
nominale.
of propellant. It's burnt its fuel. It's falling back down to Earth. So, David, the upper stage has taken the wheel. It's a little bit like a
Pilotage
fancy
calme.
orbital taxi driver, because its job is to drop off its passengers in space. Today we just have one passenger. And we've got a new engine for the upper stage. It's called the
La trajectoire est
Vinci
nominale.
engine.
Yes, the Vinci engine is one of the big innovations of Ariane 6. It provides the mission flexibility. It is designed to switch on and off up to 4 times, allowing to take different passengers to different orbits. It's the first Ariane rocket that has a cryogenic engine with this reignition capability. For the mission today, we will use the engine twice to deliver CSO3 to its orbit.
Propulsion nominale.
And after that, we will use a third burn of the engine to deorbit the upper stage.
And we had the range operations manager just back there announce that we've switched on something called the APU, the auxiliary propulsion unit. It's a new device that we've got on the upper stage. It performs a number of critical functions to
Trajectoire
enhance the
nominale. Paramètres à bord
versatility
nominaux.
of Ariane 6. Everything's going normally. We'll talk a bit more about that, David, later in the programme, so do stay tuned. But just before we do, a shout-out for the Franco-German cooperation on the upper stage.
Yes, the upper stage, which is designed and built by Ariane Group in Bremen, in Germany, with an engine designed in Vernon, in France.
Propulsion nominale.
And the whole thing was tested during the development of the
Acquisition de la télémesure par la station des Bermudes.
in a test bench designed by the German Space Agency.
And we picked up the
nominale.
signal in Bermuda. So once we release CSO3, the French Space Agency will take on their satellite.
Agence spatiale française, assure par délégation de la Direction générale de l'armement la maîtrise d'ouvrage du projet CSO. Cela va de la conception du système satellite jusqu'à sa mise en orbite et son exploitation opérationnelle pendant toute sa durée.
La trajectoire est nominale,
Pour cela,
tous les paramètres à bord sont nominaux.
Des compétences métiers pointues et un savoir-faire reconnu depuis 35 ans. C'est au CNES que sont opérés quotidiennement les satellites afin de programmer les prises de vue commandées par la Direction du renseignement militaire.
Le CNES vient de recevoir les listes de programmation à envoyer au satellite CSO. L'équipe mission a préparé les automatismes permettant de transformer les listes reçues en ordre élémentaire pour chacun des satellites. Les ingénieurs mission surveillent le bon déroulement des activités pour intervenir en cas de problème et ainsi maintenir un très haut niveau de disponibilité du système pour les utilisateurs. Les télécommandes sont prêtes. Pendant ce temps, l'équipe bord veille au grain. Son rôle, assurer la bonne santé des satellites. Elle réalise des activités permettant d'anticiper les problèmes sur les satellites afin de garantir leur fonctionnement et une disponibilité maximale pour les utilisateurs. En cas d'anomalie, elle mène les investigations pour identifier la cause et réaliser les opérations de remise en condition opérationnelle du satellite. En parallèle, l'équipe dynamique de vol vérifie les résultats de la détermination d'orbite qui calcule la trajectoire réelle du satellite. Si celle-ci s'éloigne trop de l'orbite nominale, alors l'équipe programme une manœuvre de correction d'orbite. La trajectoire réelle est utilisée pour surveiller les rapprochements avec les autres objets spatiaux. En cas de risque de collision, l'équipe programme une manœuvre d'évitement. Cette trajectoire est également utilisée pour piloter les stations au sol et la programmation des prises de vue. L'équipe sol est responsable du bon fonctionnement des moyens matériels et logiciels du centre de contrôle pour l'ensemble des métiers.
La propulsion est nominale.
La surveillance quotidienne des systèmes informatiques permet d'intervenir au plus vite dès qu'un incident est détecté. La moindre défaillance est traquée et corrigée en un temps record. Elle apporte également son expertise aux autres équipes pour tout besoin d'évolution de leur logiciel. Puis vient le moment fatidique.
Les paramètres à bord sont
Depuis
nominaux.
le centre d'opération du réseau CORE, les antennes prennent le relais. C'est le point névralgique à partir duquel elles sont pilotées pour émettre des télécommandes et recevoir les télémesures. La station d'Ossa Galicius est désormais connectée au satellite CSO en visibilité. Retour au CPCC. Maintenant que le satellite est connecté et positionné sur son orbite mission, le contrôleur supervise le bon déroulement des dernières activités. Tout se déroule comme prévu. Les télécommandes sont envoyées. La direction du renseignement militaire réceptionne les images à usage défense et les exploite pour assurer la sécurité du territoire.